Section 1.1, number 64. We're given a story of a personal watercraft we bought for $8,100, and it depreciates at $929 a year for the first 6 years. Now it says that we should graph this in the appropriate frame. Now T, we're restricting between 0 and 6. This is a calculation for the first 6 years. So nothing past here is actually any good for this model. We certainly don't care about any of the negative values. Okay, so our window includes the 0 to 6. I've included more because it's nice to kind of see where we would go if we went beyond, but the model is only good for the first t between 0 and 6. Problem B says we want to figure out what the t is when we're at $5,545.25. Now that's going to be somewhere around in here, so it's going to be somewhere approximately, say 2.75-ish. Okay, so that's what the graph tells us. So if we do a calculation and we get something close to that, that's a good verification that we've gotten the right value. If we get something that's way off of that, then, well, then we have to recheck our calculations. The graph is there to kind of help us along. Right, so what we want to do is we want to set y equal to $5,545.25. That's going to be equal to our 8,100 minus 929t. Now, we're solving for t, so we need to get everything else to the other side. So we're going to subtract the 8,100. That'll cancel there. Minus 8,100. Okay. So the subtraction, we're going to do 0.75, 495, 05, 8 becomes a 7, 25545.75. And negative, of course, right? So that's going to be equal to our negative 929t. All right, so we still want the t alone, so the next thing we do is we divide both sides by our negative 929. All right, so the negatives will cancel out. This entire thing cancels out, leaving us a t on the one side. And if we plug this in, divided by 929, we're going to get this is 2.75. Hey, look, my approximation turned out to be exact. So if I had gotten something like 7 or 28, that doesn't match our graph very well, but this actually does. So that gives me confidence that I've done the calculation right, since both methods, graphically and algebraically, have led to similar numbers. All right, now let's look at problem 3. So part C of number 64 says when we're at about 5.5, roughly where are we on the graph? And it looks to me like we're approximately 3,000. Okay, after 5.5 years, we still have about $3,000 worth of value left in our watercraft. Now, if we want the exact number, we can plug in our values, set t equal to 5.5. So it's going to be 8,100 minus 929 times 5.5. So 929 times 5.5 is 5,009. 8,100 minus 5,109.5. We add our 8,100 to that. So we're going to get that this is exactly 2,990.5, which is awfully close to my 3,000. And since the numbers are close, that gives me confidence. I've done 2 methods. Both methods have given me pretty similar results within the accuracy of the ability to read this graph. And so I feel pretty good about that.